So we're now continuing on with our discussion of key methods in different classes that are part of the common fork join framework, or the Java fork join framework. And we're going to focus here on the key methods in the Java ForkJoinPool. And you'll see that there's a bunch of methods here. We're not going to look at all of them. We're just going to focus on a few of them that are probably most relevant for what you're doing and most people's use of these classes. So remember, we talked before that ForkJoinPool extends the AbstractExecutorService. And because it does that, it ends up with a bunch of methods that come out of the box from the executor service, things like execute, submit, invoke all, invoke any. So let's talk about those quickly. So the execute method arranges to execute a runnable, which is a task, which is a one-way task. There's no return value that's coming back. And it does this asynchronously. So they're useful things. We aren't going to use this very much in the context of ForkJoinPool, but it is something that you get. There's also a way to submit a two-way task. So you can see you submit a callable, that gives a value back, you get a future back to this thing, so that's how you can eventually get the result when it's finished. There's also a method called invoke all, where you give it a collection of callables, and all of those elements run in the background and background threads in the ForkJoinPool, and this call will essentially wait for everything to be done, and it returns to you a list of futures when they're all finished. And then finally, there's one called invoke any, which invokes a collection of callables, and whichever one finishes first, that's the result that comes back. All the others are canceled. There are also versions of these methods, invoke all and invoke any, that take timers, so you don't have to wait indefinitely. We are not going to talk really much at all about these methods because they don't leverage the more powerful ForkJoinPool features. So we're going to focus on the powerful stuff, but I want you to be aware that this stuff does exist. These are the methods that we care about: execute, invoke, and submit. And you'll see that what they all do is they allow non-ForkJoin task clients, that's the clients over here on the left, that are not part of the ForkJoin framework, just arbitrary pieces of code, to pass in various kinds of tasks, which are then run in the ForkJoinPool in a ForkJoin task-like way, because you're passing in ForkJoin tasks. So we have execute, invoke, submit. So these are, in fact, very powerful methods. This is what we're going to focus on. In particular, we're going to focus on the invoke method for the assignment that you're doing. Execute arranges to run this task in a one-way manner, not getting back a result. And it'll execute this and invoke it to run asynchronously with respect to the caller. So that's for asynchronous tasks that don't return anything. Invoke, which is what you need to be aware of for this class, will perform the task that's passed as a parameter, blocking until the task completes. You get a result back from that. So it's a two-way call. And then the third and final thing here is submit, and that submits a task for asynchronous execution, and it returns a ForkJoin task, which itself is a future. So then you can essentially use that through other means in order to be able to get the result once that computation is finished. We'll see that there's other ways of doing this kind of thing that are better using the computable futures framework, but that's a topic for another day. So those are the really important methods here, and in particular, we're going to look at invoke. Now, under the hood, there are ways to be able to set the number of cores available to the Java runtime for a given ForkJoinPool. So you can see here, here's the default constructor. ForkJoinPool takes no parameters. And what it does is, by default, it will set the number of threads in this ForkJoinPool to be the number of cores that the Java runtime is aware of. And there's a method called runtime.getRuntime.AvailableProcessors, which is funny because it's left over from the days when we didn't have multi-core systems, but we had multi-processor systems. But they've kind of hijacked that to also mean how many cores are there. So that'll return to you the number of cores. And that's what you get by default. You can also call another method where you pass in how much parallelism you want, and then that will go ahead and make an allocation to make that many threads. You might use this version if you want to have the amount of parallelism for a ForkJoinPool be less than the number of cores, because you might want to preserve some cores for other stuff. You don't want all the cores to be used for that ForkJoinPool. That's the most common way that we'd use this method. You can also get access to the common fork join pool. We'll talk a lot more about that later, but in a nutshell, that's the pool that's shared by a bunch of different parts of your code that want to be able to amalgamate all the different tasks running in the context of the common fork join pool, which has lots of virtues in terms of keeping the CPU cores humming along in a fully utilized manner as much as possible by using work stealing. And the way that that works is there's a method called common pool that returns an instance of this common static field in the fork join pool class. The common pool is used by any fork join task that is not explicitly submitted to a specified pool or a specific pool. So this is sort of the common pool. This is probably not the best kind of pool to have if it's a high COVID density, right? You wouldn't want to go swimming in the common pool. But for a fork join task, that works perfectly well, and in fact is often the preferred way to go. There are a bunch of other methods in the Java fork join pool. I'm going to mention a couple of them because we're going to use them in some example case studies later. I just want to make you aware of them. They're not as important, but they're kind of fun and interesting. So these are used to manage various things. So we have getParallelism. If you call that on a pool, it'll tell you how many threads there are in that pool. getPoolSize returns a number of worker threads that have started but are not yet terminated. getQueuedSubmissionCount returns an estimated number of tasks that have been submitted to the pool that have not yet begun executing. This is an estimate because, of course, these things change in real time, concurrently, in parallel, et cetera. So whenever you ask this question, by the time you get the result back, there may be a slight difference, but it gives you a sense of what's going on. And then getStealCount, which is actually a really useful method for diagnostic purposes, returns an estimate of the number of tasks stolen from one thread's work queue by another. So this is useful to get a sense of whether your use of the fork join pool is having a high steal count or a low steal count. The bottom line is that some algorithms work better with low steal counts because you can partition things up by a divide and conquer approach, so less stealing is going on. Stealing is used to maximize utilization, but there is some overhead from having to steal. So you'll sometimes see that if you have two algorithms, one of which has lots of steals, one of which has fewer steals, the fewer steal approach may perform better. And we'll talk about that with a case study a little bit later. So that's the end of the key methods in the Java fork join pool.